Good afternoon. My name is Charles Neimog. I'm from São Paulo, Brazil, and I am doing my PhD at the University of São Paulo. But the research presented, organizing Just Intonation pictures through Xenakis, Sieves, and prime-decomposition, was supported and developed at the Federal University of Juiz de Fora. The aim of the research is to develop one way to organize just intonation pictures using the seeds of Xenakis in an electroacoustic and acousmatic environment. So my presentation will have three parts. The first will be some compositional and musical context and environment, mainly about the theory of Erv and Ben Johnston. In the second part, I will present briefly the work developed and how we can use the decomposition of prime numbers, mainly through the research of Exarchos and Erv Wilson, to understand numbers resulted from sieves operation and apply these numbers to some tools that will create set of pitches based in the theory and process of Erv and Johnston. I think that the main contribution of this approach is not the pitches generated, but the set of ways to interpret the set of pitches. In the final part, I will present OpenMusic and OM Shark libraries, OM Just Intonation, and OM Sieves. So in short, the tonality diamond limit 11 of part. This means that limit 11 means that it has no numbers in their partial harmonic identity perspective larger than 11. For example, the number 20 here will be just 2 octaves higher. Or one major third less 14 cents. In this OM patch, on the right, we have the object diamond that will build the tonality diamond limit 11. In sequence, ratios will be converted to mid-cents, use the C4 fundamental. Each of these shorts is one of the diagonals of the tonality diamond, and the box with the numbers is the interval structure of each of these shorts. As we can see, all the shorts has the same interval structure. In other words, we can claim that all the shorts in the diamond theory O tonal shorts, they are the same short in different position, which will give to the tonality diamond one very homogeneous harmonic characteristics. Yeah? The same will occur with the inverted short, the U-tonal shorts, they again have the same interval structure, and we can see that O-tonal and U-tonal shorts have inverted intervals, like the relationship between C major and F minor start from the note C. So one very quickly look at the pitch system by Ben Johnston. It is a pitch set build stacking the intervals of 5x4, 6x5, 4x3, and 3x2 until they start to overlap. This builds a pitch set of 15 pitches, and this could be done with this patch here. Huey, 2005, one of the researchers of Johnston Music, will claim that Johnston is a very intuitive composer, so he will test some shorts and choose some of these shorts using ways that, in this case, this system is used in the string quartet number 2 and number 3. We don't know how is the ways that he is choosing shorts. So this pitch set became a very large pitch set that I cannot interpret. Maybe I could plug it one MIDI keyboard, but I am inside a body that learned tonal music and play Mendelssohn, Bach, and maybe one piece of Debussy. So it's very probably that I will choose the notes that are part of some short that I know how to play. Or my musical memory will influence my compositional decision, and this of course has no problem, but I do not want this. So in this important thing of the research, this is one way to see all these pitches, mainly using the sieves. Summarizing then this compositional work, the theories of just intonation normally have shorts and systems with a very constantly presence of one fundamental pitch. Johnston, it's maybe one of the composers that this is not very true. So it's important yet ways to create bridges between different just intonation structures. For example, go to the tonality diamond by Harry part, then use pitches from Ben Johnston music or systems, then use tempered music and make possible this kind of use the use of different microtonal structures. And this is an important point of this research. I want to ways to work with electroacoustic music. So with manipulation of timbres, build coherence between timbres and pitches, beside other ideas. So this approach used to build these ways to work with this theory. It's very influenced by the work of Dimitri Exarchos. When I read it, I see that it's very applicable to the microtonal structures. And then I read the work of Erv Wilson that maybe could help me a little bit more. This figure here, it's an hexagon structure by Wilson. All the vertices of the geometric structure represent one pitch. In the hexagon, the multiplication of two numbers that belong to the vertex. For example, the vertex 5, 7 in red will represent the pitch 35 or the harmonic 35, that it's 5 times 7. The connections between vertices represent pitches that are in one same harmonic series. So this is the great thing about the theory of Erv Wilson, the connections between pitches. In Texani, the simplest combinations produce set, that it's the name of this theory to build geometric structures. We have 4 different harmonic series because we have 4 different numbers: 1, 3, 5, and 7. Then 1 will be one fundamental of this geometric structure: 3, 5, and 7. So how we can see, all the vertices connected share one same number. For example, the vertex 5, 7 is connected with 3, 5 and 1, 5 because they share the number 5. And 5, 7 will be connected with 1, 7 and 3, 7 because they share the number 7. The vertices connected with the same number in hexani, they build one triad or a set of 3 vertices. For example, the vertices in green 1, 5, 5, 7, and 3, 5, they are one set of 3 notes that are represented by the harmonics 5, 35, and 15. If we see the intervals that compose the set of notes, we will see that it is the same interval structure of the numbers 1, 7, and 3. What means, of course, that these two sets of numbers, they are the same short in different positions, and of course will have the same harmonic identity. Then if we invert the way to do the process by Wilson, what means not create the numbers using multiplication of set chosen number, but decompose the numbers from Sieves to C, the prime multiplications that will generate these numbers, then we can build connections between Sieves and C, harmonic relations between them, between these numbers resulted from Sieves, and interpret this set of numbers in a microtonal sense, maybe in a combinations produced set sense. And this is based mainly in the Exarchos claim that when we decompose the sieves, we are able to see transformation that might not be as obvious in the actual scale. So Exarchos is applying this idea to the modulus of sieves. I am applying it to numbers of the sieves. In this image, we can see this idea with small numbers. The prime numbers are where all the harmonic series born, and the dots represent harmonics that can be interpreted with more than one way when we apply the decomposition of these numbers. For example, 22 will be decomposed with the number 2 and 11, so it is part of harmonic series of 2 and 11. With other example, the decomposition of the number 35, that will result in 5 and 7, will allow the interpretation of 35 how the 70th harmonic of 5 or the 5th harmonic of 7. Then we have again two fundamental bits that can be used to modulate between different set of pitches, yeah, or different harmonic series. And we can of course do this process with more complex sieves, like this case here. The output of the OM patch will be all ways to interpret the numbers resulted from sieves. For example, 77 could be interpreted how the 11th harmonic of 7 or the 7th harmonic of 11. 133 could be interpreted how the 19th harmonic of 7 or the 7th harmonic of 19. And then, or maybe one. Yes, and then we can see connections between these numbers like 77, 231, 133. They are part of one same harmonic series that born into the number 7. But we can use, for example, 133 to use to go to other pitch set or that have a fundamental pitch in the 19. Yeah. Of course, this is a simple sieve used for didactical purpose, but I think that it's possible to understand this kind of structure that will maybe help us to modulate between different harmonic series fundamental pitches. Yeah. Finally, we can use sieves to work with other parameters that know pitches, like rhythmic tree, that is a great tool of OpenMusic, melodic contour, how is in this patch. We can change timbres. The description of this OM patch is available in the article A Manipulação do Timbre a partir de estruturas de afinação justa in Portuguese, but it has the English presentation on the YouTube of Symposium of Música Nova. So finally, we have developed two libraries for OpenMusic and OM Sharp, OM Sieves that use the Kriblis implemented by Carlos Ago and Moreno Andreada in the Math tools. And OM Sieve is available in my website and GitHub page, and the same for OM Just Intonation. In OM Sieves, I basically reformulate all the names of the objects to English, so Kribbles became Sieves. Will be possible to build sieves a little bit more quickly. It's possible to use the syntax proposed by Arisa 205. It's possible to decompose sieves, in other words, see the unions that will build some numbers result. This is an example of Arisa 2, and of course other things. In OM Just Intonation, I implemented theories of Harry Part, Ben Johnston, and Erv Wilson that has two theories. One is called moment of symmetry and the combinations produce set, and the ideas described in this presentation beside other ideas like the timbre manipulation with just intonation structures using the sieves, of course. Well, I think that this way to approach the just intonation can help in some compositional environment and maybe help to bring the microtonal thinking for electroacoustic and acousmatic music. Of course, with the help of sieves, I think that it will be possible to organize large microtonal structures once that in electroacoustic environment we don't need to deal with the limitations of the traditional instruments. So this was my presentation. I'd like to thank the financial support by Federal University of Juiz de Fora and of course the Xenakis Commission to make my presentation possible in an online mode, and the possibility to share my work and my research to all the great Xenakis researchers that will be in Greece. Yeah. So thank you very much.